Hi guys, welcome back to another STEM Helps video. Today we will be going over triangle theorems part 2. Most of you hopefully have checked out my first video that goes over the congruent triangle theorems, and today we will be covering the similar triangle theorems. But to begin, many people often confuse the meanings of what congruent means and what similar means in triangles. Congruent means that both triangles are equal in every mean possible. So in this case, you can see, without any values given, that this triangle is bigger than this triangle. So we can't say that it's congruent. But however, this triangle, even though it's bigger than this one, if the angles line up, like this, then they are similar. Or if the sides line up, or if the side angle side lines up. And that's what we'll be covering next. But I just wanted to go through that real quick so that way many people will have a refresher on what it means to be similar. Another thing that many people forget about is the sides. The sides do not have to be exact like they would have to in congruent theorems. The congruent theorems would say, like for example, the side theorem, this side has to be equal to this side. But in this similar situation, it's something completely different. So let's begin. The first theorem that I'm going to cover with you guys today is called, nonetheless, side. But you don't want to confuse this with the congruence theorem. This theorem states that if the lengths of the corresponding sides of two triangles, so let's draw some triangles right here. Notice how this one's bigger than this one. If the lengths of corresponding triangles are proportional to one another, then the triangles must be similar. So let me explain what that means. Let's say this value is 4, and this value is 8. Let's erase this x. And then we'll say that this is 4 here, here's 2, and then 6 and 3. So what this is saying, this is triangle x, and this is triangle y. This side right here, 4 and 8. 4 times 2 equals 8. Let's look at this one. 2 times 2 equals 4. And then the last side, 3 times 2 equals 6. So you could say, inversely, that this triangle, that these lengths are 1/2 the lengths of this. Or you could say that these are twice the lengths of that. So 4 times 2 equals 8, 2 times 2 equals 4, 3 times 2 equals 6. Or if you divide these by 2, then you could say it's 4, 3, and 2. So when you see sides that are proportionally the same, then you know they must be similar. Let's move on to number 2. The next theorem is called the angle-angle theorem. This states if two angles of one triangle are congruent to two angles of another, then the triangles must be similar. So in this case, let's say this angle is 30. This angle is also 30. Let's change these numbers up. I'll say this is 5, and I'll say this is 3.5. And this is 105. This is 105. So we know this isn't side theorem because each side is not proportional to one another. 3.5 is not proportional to 5 in the same ratio that 4 to 8 is. 3.5 times 2 is 7, not 5. But if we have the angle-angle theorem, then we can conclude that they must be similar. So let's take a look. 30 degrees and 30 degrees, okay. 105 and 105. Because we have two angles that are congruent in the similar triangles, then we know both triangles must be similar, regardless of the sides. What would happen in real life is they wouldn't give you this side, they would give you x or something, or they wouldn't give you any sides, and this would actually turn out to be proportional to the rest. But I just used that as an example, that way you wouldn't be able to use this. The last theorem is called the side-angle-side theorem, very similar to the congruent theorem that's also side-angle-side. But in this case, like we touched base on number 1, it states if two sides in one triangle are proportional to two sides in another triangle and the included angle within them are congruent, then the two triangles, must be similar. So let's take a look. Let's say they give you 30 degrees. That's it. And they give you x, and they give you y, and they give you 5 and 10. And then they'll also in the corner say that y is equal to 2x. So let's look. We have x, which is 2 times y, 30 degrees. 30 degrees are the same, and then 5 and 10. Well, if this triangle is twice the size as this, let's check. 10 divided by 2 equals 5, or 5 times 2 equals 10. So we know side angle side must work for this one. And that's what this means. If both sides are proportional to each other and the angle between them is congruent, then both triangles are similar. So let's do some practice problems with these theorems. So first, you'll notice that both triangles are not the same in size, so you can automatically conclude that both are not congruent. So that's when we have to switch over to similar theorems. So let's say they give you this, so you know they are right triangles, and they will give you this. They won't tell you what the value is of these angles, but because they have the same amount of round circles, then we know they are congruent. Let's say this. So they say that angle x is congruent to angle y. So let's go down. Side, side, side. Well, we don't know any of these sides on this triangle, so it can't be that. Maybe, but we don't have enough evidence to prove this. Let's look here. Angle, angle. Well, we see these angles are the same, and it says that angle x is equivalent to angle y. So this is right. Let's move down to here. Side, angle, side. No, they don't give us any side values, so this cannot be proven. So here we would use angle, angle. Let's do one more. Let me think of a good one. They'll give you this, and then they will give you, they'll give you 6, 12, and then they will give you 4, and 8. And here is x and y. So we don't know what x and y equals. So let's go down. Side, side, side. Well, we don't know what x and y equals, and they don't give you any information saying if they're proportional to each other. So there's not enough evidence to prove this. Let's look at angles. Do they give us 2? No, I only count 1. So we can't prove angle, angle either. Let's look here. Side, angle, side. We have 4, we have 8, and we have 6, and we have 12. So we do have 2 sides. Let's see if they're proportional. 4x equals 8. Divide the 4 out. X equals 2. Okay, so let's see. 6x equals 12. Divide the 6 out. X equals 2. There we go. So we know these are proportional, and they are giving us the 90-degree mark, so we can declare that these triangles are similar under the side angle side theorem. Later on, we will be using these theorems to help us navigate the proofs of triangles, but that will be later videos coming on. But I hope these 2 videos have helped you understand what the theorems are, what they mean, and ultimately the difference between congruent and similar triangles, because they are not in fact equal and they do not mean the same thing. So don't mix that up. That's a big point in this. But thank you for watching, and we will see you next time.